Hello and welcome to my kitchen. So we're going to start off with Unit 4, which is where we left off. And the topic of Unit 4 was going to be momentum. And so bear with me as I talk to you digitally about momentum. So what the heck is momentum? So momentum, if you take a look at the definition, it just refers to how much motion something has. And so if you take a look, there's an equation right here. The equation is P is equal to M times V, where if you look down here, P is going to be the variable that is momentum. Don't ask me where they get that. I actually have no idea. One of those mysteries of science. M is mass, and V is velocity. And so if you take the units for mass, which are kilograms, and you take the units for velocity, which are meters per second, you multiply them together, then it should make sense that the metric units for momentum are kilograms meters per second. And so I have that highlighted here on the right-hand side where it says SI units. Just a reminder, SI units means the metric system units. And so just to make sure that you're following along with me, I have an example for you guys. So if you take a look, my example is that you have a skater. Okay, so the skater is over here on the left-hand side, and the skater has 70 kilograms and a velocity of 3 meters per second. And the truck, right, has a mass of 2,000 and a velocity of 10 meters per second. And so if you ask yourself, I wonder if that's going to record. If you ask yourself, okay, so what's the momentum of this guy? Well, M times V is going to be 70 times 3. So 70 times 3 is going to be 210. And so 210 kilograms meters per second. And over here, you would have a momentum of 2,000 times 10. And so 2,000 times 10 is going to be 20,000 kilograms meters per second, which is much, much greater than the skater. But my question to you is, will the skater always have less momentum than the truck? Think about that for a second. I'll just sort of sit here. Okay. Well, hopefully you thought of the following. The skater won't always have less momentum because while the skater, has less mass, there's nothing stopping us from saying that the velocity, right, is going to be equal to, 20,000. And so I'm going to go ahead and show you an example of what that looks like. So let's go ahead. We're going to look at whiteboard right here. So we said over here that, and bear with me on the virtual whiteboard format because I'm still a little new to this, but let's say, right, that we have the momentum of the truck is equal to 20 20,000 kilograms meters per second. Okay, my handwriting is terrible in here. Well, how can we make the skater do that? So let's say that we want the skater to have 20,000 as its momentum. Oh gosh. I have a lot of respect for the Khan Academy people now. Okay, so you have 70, and then it's going to be divided by some velocity, right? And so the answer is going to be, okay, well, if I divide 70 to the other side, okay, well, then that will tell me, right, at what velocity the skater will have the same amount of momentum as the truck. And so let me go ahead and ask Alexa, what is 20,000 divided by 70?
20,000 divided by 70 is 285.7143.
All right, so you heard her, 285.7, and I forgot the rest. So we'll just say 285.7 meters per second. And so to answer the question, right, will the skater always have less momentum? No, if the skater was moving 285.7 meters per second, well, then it would have the same amount of momentum as the truck. But that's a little crazy, because if you just kind of take a look over here and you say, okay, so what's 285.7 meters per second to miles per hour, right? That is 639 miles per hour. And so our skater would be needing to go the speed of sound, essentially, to have the same momentum as the truck, which hopefully you're kind of chuckling to yourself, because, physics can be fun when you get ludicrous numbers like that. So anyways, I'll go ahead and put this whiteboard over to the side. And just to make sure that you're, sticking along, let's go ahead and do some example problems. So here's my example problem. We're going to do these 3 examples, and then we'll call it a day. So what is the momentum of a 0.2 kilogram ball that is thrown at 10 meters per second? And so here's my number 1. And let's go ahead and let's make it a bigger. There we go. Cool. Okay, so what is the momentum? So we'll start off by writing, okay, so P is equal to M times V. Okay. And so if we go ahead and plug in our numbers, so 0.2, for some reason the decimal didn't come. Okay, so 0.2, and it's going at 10 meters per second. Okay. Then, hopefully you can do that in your head. That will be an answer of 2 kilograms meters per second. Okay, so that will be our first answer. So let's go ahead and write in over here. Okay, so 2 kilograms meters per second. We'll go ahead and we'll highlight that right there. Okay. All right. What is the mass of a moving car that has a momentum of 10,000 kilograms meters per second and is moving at a rate of 10 meters per second? And so let's go ahead and do that. So we'll say, okay, so we have 10,000. Oh gosh. Okay. Okay, and just going back, it's moving at a rate of 10 meters per second. So go ahead and we'll say, okay, so M is unknown. Okay, and it's moving at a rate of 10. So if we want to solve for M right here, if we just divide by 10 on both sides, and hopefully you can do this in your head, but 10,000 divided by 10 is just 1,000. Units, kilograms, 1,000 kilograms. So let's go ahead and plug that in. All right, and very lastly, so a canoe has a momentum 1,200 kilograms meters per second when loaded with 400 kilograms of gear. What is the canoe's velocity? And so let's come on over here and let's do this. So again, the canoe has a momentum of 1,200. God, I really do have a new respect for the Khan Academy people. Okay, so 1,200. And then we'll go ahead and we'll say that the mass is 400. I'm sure you get better with this over time. And then what is the velocity? Okay, Well, hopefully I don't have to do too much of this for you, because again, I chose really easy numbers for you guys, because how many times does 4 go into 12? Hopefully you're saying to yourself that it goes into it 3 times, and so our velocity is going to equal to 3 meters per second. So we'll go ahead and we'll plug that in. Oops. And we'll go ahead and we'll highlight that. Okay. So that's the basics of momentum. I'll leave this kind of up for you guys so that you can screenshot this and you can take a look at the answers. If you do need me to go over this, feel free to ask me questions either by email or at my office hours. All right, I'll see you guys later.